Hello everyone, hopefully you're doing well. In this video, we're going to start with chapter 3, numbers in the real world. Life is filled with numbers that may at first seems incomprehensible, like a population measured in billions of people. I don't know if you ever heard that currently the world population is about 8.1 or 8.2 billions of people. You know about the US debt, national budgets measures in trillions of dollars in the US, of course, distance ranging from nanometers to light years. Numbers come in many different forms, including percentages, index numbers, consumer price index, for example, nearly always involves uncertainty. So that's exactly what we're going to discuss in this chapter, the use and interpretation of numbers we encounter in our daily lives. We have real numbers and then you have complex numbers, but in this case, we're going to focus at some point in numbers in the real world, right? Every time we deal with counting, and that's what we're gonna do. It's really about words. But we're gonna start first of all to discuss 3.A, which is uses and abuse of percentages. So we hear and use percentages all the time, and the basic meaning is fairly easy to understand. When you do 8%, if you obtain a discount of 8%, right? Discount of 8%. Or you can write it 0.08, or you can write it 8 over 100. The same, you can have sales tax, state tax. Let's say state tax. So everything you buy, maybe it's 7%, so that's different ways of expressing it. So as the chapter opening activity, so we can talk about the interpretation of percentages that can be quite subtle. As another, let's say, another examples, the market share for electric cars, for example, this year, is up to 43% to 4.2%. It all depends what we want to do with this because it's all about abuses. Surveys shows that even highly educated people are sometimes stumped in trying to understand how something can be up to 43% to 42%. So that's different ways of talking about percentages. So we will investigate some of the subtle use and abuse of percentage in this unit, very important. But three ways of using percentages, uh, we're gonna go with one first example. So a total of you know, we can say a total of 13 thousand newsrooms employees, 2.6% of the newsroom workforce lost their job. So it's a 2.6% of that 13,000. So we can see it. How to describe change. First of all, you see the fractions we gave you that as fractions we give you. But how about to describe changes? To describe change, like the company stock fell 15% last week to $44.24, $425. You see? Yeah. On a cross-examination, so you see these statements, or let's go with the last one, comparison for the new battery lasts 175% longer than the older one, but cost 10% less. As we said, we need to be careful how we use percentages not to abuse them. So when we look closer, we see each statement uses a percentage in a different way. You see, the first one uses a percentage to express a fractions, right? So that's to express a fractions of the total work force. The second use a percentage to describe a change in stock price, and the third use percent to compare the performance and cost of a battery. So that's very important to see it that way. So percent is a fancy way of saying divided, percent means percent, percentage means divided by 100, right? So it's a fancy way to say that. So P%, if we said, for example, 4.2%, 4.2% would be, instead of saying 4.2%, it means 4.2 divided by 100. If you divide by 100, it's the same thing moving the decimal point for 2 units to the left. So that would be 0.042. If we do, for examples, 44.25%, remember there is a point here, that means 44.25 over 100. You can move it 2 units to the left, so 44.4425, right? So always go the same way. If the market share for electric cars was 4.2% and a total of 100,000 cars were sold, that means we need to take 4.2% of 100,000. So for example, here, if we take 4.2% of 100K, meaning it's 0.042 times 100K, so 100,000, because of means multiplication. So that's very important to see it that way because we have so many examples we can do. But in the meantime, let's go with the first examples here. In the following statements, express the first number as a percentage of the second number, right? Because they said Joe Biden won 306 electoral votes in 2020 out of 538, right? So because what we ask you to find is like he I mean, the total, identify the total first. The total is always the one that go in the denominator. So that means we need to do 538, but he won 306. Out of means means divisions, right? Joe Biden won 306 electoral votes out of 538. Disregard 2020. You can put it at the front. In the front, you can say in 2020, Joe Biden won 306 electoral votes out of 538. So the biggest number is in the denominator, but it's mostly because they said out of. So we can rewrite it 306 over 538 that you can express in decimal using your calculator, which is 569, that you can say it's 56.9%, right? You can write it that way with no problem. So what I mean by, if I put a here, we know it's 306 over 538 equal 0.569 equal 56.9%, because if you have decimal and you want to express it into percentages, you move the decimal points 2 units to the right. Okay? If that makes sense to you, it makes sense to me. We can go and check another examples. We said the full time. I think we need to put the full time. Um, I said two full time size for that was a typo. All right. We said the full time. Um, The full-time year-round median salary for U.S. worker in 2000 was $30,846 compared to 52,800 in 2020. So in 20 years, the median U.S. workers salary goes from 30,846 to 52,800. So that's what happened. Now, what they ask you to do, express the first number as a percentage of the second number. That's what they said. All you need to do with it is to put the first one on the top because they said, right, the first one in function of the second one, 52, 800,000. So then you do the math using your calculator. That would give you 0.584, so 58.4%. So that's how, that's the difference. That's how it changed. All right. Um, Now, the next, we can go with another examples. In this case, we said or one on one particular day, there were 3,843 deaths attributed to the coronavirus in the United States, and 119,014 cases. So remember, what they ask you to do again is to express the first one in functions of the second one. All you need to do, C, you do 384 over 119,014. So again, in these examples, it gives you 0.032 2.3% because we can move with this decimal points 2 units to the right. Again, we can see some other examples using percentages. For example, here we talked about a presidential. I know it looks like the same thing we were just doing. But what we said here, an opinion polls find that 35% of 1,069 people surveyed said that the president is doing a good job. Okay. How many said the president is doing a good job? So here, they give you the polls, 35% of 1,069. Remember, of means multiplication. They said 35% of 1,069. If you express this, if you translate it into mathematical models, because of indicated multiplication, 35% of 19 response cycle, we said we can put 0.35 in decimal of mean multiplication. 1069. Now you can do the math. Equality mean is. So if you do that, we find using your calculator, when you multiply this, it gives you 340, 374.15. Remember, we survey people. So we cannot have decimal for that one. It's either 374 or 375. So we can say about 374 people said the president is doing a good job. So we can round the answer to either 374 or we round it to 375 because we need to obtain a whole number. So it's about, I round that one. So we can say it's 374 people said the president is doing a good job, right? Said the president is doing a good job. Okay, so that's mostly what you need to see with this one because it's very important. You always round your answer to the nearest whole number because we're talking about people. It really makes sense when you talk about people to use whole numbers instead of that. Now, using percentages, to describe changes, we can say that percentages are often used to describe how a quantity change with time. Uh, you know, I think we can take an example like if you have the population of a certain town that's raised from 10,000 a decade ago to 15,000 today, so we can express the change in population in two basic ways. So because the population rose by 5,000 because it was 10,000, now the new population is 15,000 after after 5 years, after 10 years, because we say a decade, right? Because it was from 10,000 to 15,000. We say that the absolute change in the population was 5,000. So the absolute change describe, okay, the actual increase or decrease from a reference value to a new value. So reference value for us, population increase, increase from 10,000 to 15,000. So absolute change, so absolute change is 5,000, right? It's 5K. You see? So we said if a population from a small town rise from 10,000 to 15,000 in 10 years, so we said that it was by 5,000 because from 10,000 to 15,000, we said that is an absolute change in the population that is 5,000. So we said the absolute change describes the actual increase or decrease from a reference value to a new value. So I want you to put this one somewhere in your cheat sheet or whatever notebooks you use to put notes as the formula we use to compute absolute change. New value minus reference value, that means the original values, right? Now, because the increase of 5,000 people was like 50% of the starting population, it was 10,000, now we make it 15,000. So if you do 5,000 divided by 10,000, it make it 50%. Right? It's rise, people 50,000 of the starting population. We say that the relative change in the population was 50%. So how do we find relative change? The relative change is the size of the absolute change in comparison to the reference value and can be expressed as relative change is the absolute, okay, relative change equal absolute change over reference change, reference value. Or if you want, you know what is absolute change, right? Absolute change is new value minus reference value over reference value. Okay, so that's it. So that's the formula to find relative change. You have the relative change and you have the absolute change. I believe now we have enough to do that because, in general, calculating an absolute or relative change always involves two numbers, a starting number, or you call it reference value, and a new value. Once we have identified these two values, we can calculate the absolute and relative change with the formulas in the we just gave you here. So absolute value, absolute change equal new value minus reference value, and relative change equal absolute change over the reference value. So you can see that the absolute and relative changes are positive if the new number if the new number is greater than the reference value, right? And it's negative if it's otherwise. So things that we're gonna see, but let's go over a few examples. It's very important. So from times to times, we go with some examples that we can do. All right. So for this one, the access to you know the access to verifying find both the absolute and relative. Absolute and relatives. Remember, absolute change, new value minus reference value. And we have relative change equal absolute change over reference value. All right, now let's go with A. The estimate number of refugees in the world increased from 8.7 to 26.6. So now we only need to identify what is the reference value, what is the new value. If you can identify these two, what is the reference value here in A? Yes, 8.7. What is the new value? 26.0. Now we know in this case, absolute change, apologize for my handwriting, equal new value because we need to find the absolute change first. So that would be the new value 26.0 minus 8.7. And using a calculator, you would find 17.3 millions. 17.3. I put capital M for millions. All right. Now the relative change. All you need to do is take the absolute change, which is 17.3 over the relative change, 8.7. Now, what is it exactly? Because this one is in percentage. Sorry, the relative change, the absolute change is a number, all right? It's a whole number, but the absolute change is a real number. I mean, not real number, it's a number. But the relative change is a percentage. So we're gonna have when we do 17.3 divided by that one, it gives us 1.99. Oh my God, that's is like 199%. So it's in percentages. So that means in 15 years, the estimated number of refugees increased by 199%. So it's like almost 200%. So if you go with B, again, reference, that means the starting number is the number of AM radio station decreased from 4978 from in 1990 to new value. The new value is 4560. Now in 2020, you see like in about 30 years, there's a decrease. So meaning everything would be negative because that's what we said. We said that the absolute and relative changes are positive if the new value is greater than the reference value, but negative if the new value is less than the reference value. And that's what's going to happen here. If you try to compute the absolute change, remember, absolute change, we said new value 4560 minus reference value 4978. What is the answer for this one? Let me grab a calculator. We said that for this one, um, I don't have it. I don't have it in a calculator. Let's try. It is negative right? Help me with your calculator, please, because I'm trying 48, 4978 minus 45, 60. So that would give us negative 418 stations because we said the number of AM stations, decrease. So now if you go with the relative change, in this case, relative change, remember that should be in percentages. That means negative 118 over the reference number. That is 4978. Now, when you divide these two, it gives you a decrease of 8.4, or we can express it in decimal first. Let's express it in decimal. We get um, 0.084. So we said it's negative. There is a negative, negative 8.4. But if we talk about decreasing, we don't need to use the negative sign. We can say it decreased by 8.4%, right? 8.4%, it decreased. Decrease means negative, right? All right, that's a good example for this one. But remember what we do with absolute change. We talked about the absolute change and relative changes, but using percentages to compare. All right, if we use the percentages to compare. To compare for comparisons, we can use it to compare two numbers, right? Uh, so we can consider, let's suppose I'm gonna just, I don't want to write my examples down, but suppose we want to compare the price of a 50,000 Mercedes to the price of a 40,000 Toyota. So the difference between the price of Mercedes and Toyota is 50,000 minus 40,000. That gives you 10,000, right? Now, the Mercedes costs $10,000 more than the Toyota, right? Toyota 40,000, Mercedes 50,000. So Mercedes is 10,000 more than it. So we can express this difference as percentages of the Toyota. So 10,000 over the difference between these two and the price of the Toyota, that is 40,000. 10 divided by 40, that gives you 25%. So in relative terms, the Mercedes cost 25% more than the Toyota, right? So because we are comparing to the Toyota price, we say that the Toyota price is the reference value because we divide by it, right? Notice that the reference values follow the word then, right? It's greater than, right? The Mercedes price is the compared values, right? So that's what we are trying to explain in these examples here. We can now define the absolute and relative difference between the quantities, much as define absolute and relative change. So the absolute and relative difference are positive, because we said the absolute difference is the actual difference between the compared value and the reference value. Like, you know, Mercedes costs 50,000, Toyota costs 40,000. We want to compare with the price. So we said absolute difference, compared value minus reference value. That's the first one right there. When you want to compare the price of two products. Now, the relative difference, as we said, relative difference describe the size of the absolute difference in comparison to the reference value and can be expressed like you take the absolute difference, you divide it by reference value when you multiply it by 100% because it would be in percentages. Again, write those on a cheat sheet where you can rewrite and compare. And of course, it's very important to see where this one gonna bring you. Now, our next examples would be something for, when we compare. Okay. So we're gonna take salary comparison. Kyle's increase, salaries increase from 25,000 to 35,000 over a 3-year period, right? Whitney's salary increase uh, from 30,000 to $42,000 over the same period. Whose salaries increase more in absolute terms and in relative terms? So we need to look for the differences between those because it's very important to see the difference. So the color's absolute change in salary, absolute change, right? What is the absolute change for color? I think we were supposed to say Kaya, but we said color. Absolute change. How do you say the absolute change again? Absolute change equal new value minus reference value or the start one, right? So what is Kyle's absolute change? 35,000 minus 25,000, that give you 10,000. I don't know if you agree with that. And now it says, what is the relative change? Because they ask us, they don't say it's change. It said, what salary increase more in absolute terms? But we said we do absolute change. Let's do relative change for Kyle. You know that would be the absolute change over reference value. So meaning 10,000 over the starting point value of 25,000. If you agree with that, we can do, um, you know, um, yes, we can do that way. 10,000 over 25,000, that give you zero point 0.4. Or is it 40%? So at this point, we can do the same for Whitney because remember, we only do Whitney's absolute change because now we do Kyle, let's do Whitney. Remember, new value 42,000 minus 30,000. What would that be for Whitney, please? Because you must have a calculator and it looks something very easy to say is 12,000. Okay, but relative change is the absolute change 12,000 over the reference value. That means the the starting salary. And when you do 42,000 minus 12,000 over 30, so oh my God, that's give you still the same 40%. So you see absolute change difference, but the increase is the same. So going from 25,000 to 35,000 is the same going from 30,000 to 42,000, right? Because in terms of relative changes. But now we know that Whitney's salary grow more in absolute terms. Okay, Whitney's salaries grows more in absolute terms, but the relative change was the same. All right. So Whitney's grows more. I don't want to write it, but I want you to listen to what I just said. I said that Whitney's salary goes more in absolute terms, but the relative change was the same. This happened because we are comparing Whitney's larger absolute change to her also larger initial salary. So that's what happened. But they ask you, would salary increase more? Same relative change, but Whitney's absolute change is bigger. Right? So there is change one way, but that was a good example. Now, we're trying to go over many different ways of seeing, percentages. When you compare, for example, population that triples in size from, for example, 200 to 600, like it triples, like there are two equivalent ways to set this change with percentages. Like very important to using more than. The new population is 200,000 more than the original population. Like you go from 200 to 600, we can say the new population 600 is more than the 200% more than the original population. So different ways of writing it. So we can, if we want, we can write the relative change. The relative change means that. But if you use of, because I will just give you more than. If you use of, the the new population is 300% of the original population. Which means that three times the size of the original populations. We can see it. Different ways of writing. So of versus more than or less than if the new population or compared values is p% more than the reference value, it is 100 plus p% of the reference value. So you just write it like, if it's increased by 25%, then whatever you have, you need to multiply it by 1.25. That means 100 plus 0.20 plus 25, that make it 125. So 1.25, right? If the new or compared value is p% less than the reference value, then you subtract it and it should be the same. We have a few examples like this that we can follow. All right. Let's say here they give us a few exercises that we can just fill up, the access to complete, do they access complete the following sentences or fill in the blank for those examples. All right. One of them is we're gonna go with it right there. It says that the population of Michigan is 63% greater than the population of Missouri, right? We have the population of Michigan is 63% than the population of Missouri. So Michigan population is what of Missouri? I'll let you think about it, right? Michigan populations, if you want to do some computations, in this case, you would realize that it's 163%. Michigan population is 163% of Missouri's population because 63% more than express a relative difference, right? And this equivalence is 100% plus 60. That's what we just said in the previous one, 100% plus the percentage. So if you go for A, 100%, 100 plus 63%, that give you 163%. So we can say that Michigan's population is 163% of Missouri's populations, right? Very important. We can do B. I'm gonna do B also. We said the net worth, all right? The net worth of Warren Buffett is 14.5% less than the net worth of Bill Gates. Remember, if it says less than, you need to subtract. That's what we said. So net worth of Warren Buffett net worth is 85.5%. 85.5 because for B, we're going to do 100 minus 14.5. Okay, so that gives us 85.5%. So we can either subtract or multiply because we said that Warren Buffett's net worth is 85.5% of Bill Gates' net worth because 14.5 less than express a relative difference in salary. So in this is the equivalent of 100 minus 14.5 of the reference net worth, right? Right. I think you see it. I can do maybe one more for C. We talked about the wholesale, you know, price of a toaster is 30% less than the retail price. Then the wholesale price is how many it is. The wholesale price is about 70%, right? Since the wholesale price is 30% less than the retail price, so this one is only 70%, right? 70 percent of the retail price, which is 0.07 times the retail price. But I let the last one for you to enjoy, and hopefully you're gonna do as many examples as possible. That's our job to go over and tells you. But percentages of percentages versus percentage points versus percents. I think that's what we're supposed to say instead of percentages of percentages. So it's very important to see that. What we mean by that, percentage changes or comparisons can be particularly confusing when they value themselves as percentages, right? Suppose a bank increase its mortgage interest rate from 3% to 4%. That's something you hear for very often. The bank said, oh, we increased our mortgage 3% to 4%. So it's tempting to say that the interest rate increased by only 1%. That's not true. The statement is ambiguous at best. The interest rate increased by 1% point, but the relative change in the interest rate, is something different. You need to do the relative change. Remember relative change? Relative change, meaning we said the relative change, meaning take the new value minus the reference value, like the absolute change in the top over the reference. So if we said if the mortgage increased from 3% to 4%, new value is 4%, it was 3%. Over 3%. So you cannot say that because it's increased from 3% to 4%, you cannot say that the interest rate increased by 1%. That's not true. You need to look for it, 4 minus 3 divided by 3. So that should give you kind of 33% in at the end. If you do that decimal, then you convert. All right. So that's very important to see it that way. In other words, you can say that the bank raised the interest rate by 33%, even though in the actual rate increased by only 1 percentage point. That means 3% to 4% represent 33% in increase. So the absolute change in the interest rate was 1 percentage point. With the relative change, it is 33%. So that's what we try to explain in terms of here. All right. We can solve multiple problems, but let's go first of all here when a change or difference is expressed in percentage. When discussing changes between numbers that are themselves percentages, you can avoid ambiguity by being clear in your wording as follows, using the examples of interest rate, then increase from 3% to 4%, right? So if you're talking about the absolute change from a 1 percentage to another, you use the word percentage points. Okay. use the word percentage points rather than a percent sign, right? So a change in the difference in this percent, assume it is absolute change or difference. With the percent sign or the word percent, it is relative change or difference. So like we said, if a bank increases its interest rate from 3% to 4%, the interest rate increased by 1 point. Something we're gonna see later. Solving percentage problems. If the compared value is P more than the reference value, then you compare it. That's, you know, relative value would be compared value over whatever you find, right? So we're gonna use this one also in examples right there and make sure that we do have enough for it. So we're gonna do all of this. So we're almost done with this section because I want to make sure that we have enough time to record it. Let's go over these examples very quick. That's very important to view more examples because this one, some of the problems that we can review, um, you know, we said the total after tax cost of a laptop computer after tax is $1,278.24. The local sale tax is 7.6%. What is the retail price? Okay. Remember what we said about this. The pre-tax price, all you need to do, you know what is, different ways of doing it. If, the total tax of a laptop, the total cost of a laptop is 1,278.24, after tax, because remember, this is how we do it. When you buy a laptop, let's say the price, we're gonna go with the price, right? We see the price. So price of the laptop, you see, plus tax give you 1,278.24, right? Price of the laptop plus tax, whatever you see is plus tax, right? What we need to find this price right there. Okay, so how to find it? The good news, we know the tax. So we know one, the tax, what is the tax? Tax is 7.6% or 0.076 of what? We have 0.076 of the price, right? Remember, that's of the price. So what we need to do, for us, let's call the price X, okay? I'm gonna call the price X because I don't know the price. Price equal X. Now, the whatever we have here is 7% of X. So we can use as multiplication. So 1X plus this give you 1.076X equal 1,278.24. Now look, if I have these fractions, because I need to add the taxes to the original price, because I can call it original price, but I call it X because I don't want you to confuse between O for original price and X, and zero, right? So we have 1.076X equal 1,278.24. If I want to solve for X, those of you who do algebra, you know you need to divide both sides by the coefficient of X, which is 1.076, 1.076. So at this case, we're gonna say that the price is 1,187.96. So we can conclude that for the pre-tax price for the laptop is 1,187.96. All right. So you see, that's a very simple example. When you buy something anyway, you must pay, all right? You must pay, interest. Now, if you look at another examples, in this one, they said during the past decade, and decade means 10 years, all right? I mean 10 years, the percentage of smokers in the US has decreased, right? This is the reference number. You have your reference or the starting value, 28.0%, and you have the new value, which is 15.1%. It decreased from 28% to 15%. What percentage of American smokers at the beginning of the decade? So remember, it decreased, from that percentage because it decreased from that percentage to this one. So for us, that we want to know what percentage of the Americans was in this situation. First of all, what you need to remember, you do have 28% minus something, minus what? Because we need to find, uh, uh, you know, it's decreased 28%. Oh, no, no, no. You had 100%. Right. Sorry. You had 100% of because this is how you see it. During the past decade, the percent of smokers in the US has decreased, not 28%. That means you had 28% now. It's 28% minus 100% minus 28%. All right. What percent of American at the beginning of the decade? So that's what we need to find. What is X? Right? We need we need to find X. Okay? Does that make sense? So if we follow what we have, because we have X at the beginning. Oh, sorry, I'm gonna need to do it different ways. We have X, the population was X%, all right? When you subtract 28% from it, it decreased. So what we're gonna do to find the beginning of it would be 15% that it decreased, or you can call it 0.15 over 100% minus the 28.0%. So that's how you're gonna find the percent of American that smoke at the beginning of the decade, right? So that's about 0.21, so 21%. So we said the percent of Americans that smoke at the beginning of the decade was about 21%, was about 21%, you see? So there are different ways of computing the same thing because here we try to solve real life problems. Those are things probably you would see, you know, and we can try to solve the problems because those type of exercises, we would see them all the time. Like if you do, um, you know, the the other one, the total, they said like the 4,550 men in the arena comprise 85% of the people in the arena. How many people were in the arena? So that's very simple. You just divide by 85% or multiply, uh, you know, If you do 4,550 over 0.85, you should find the number of people that was in the arena. So that's an example, it's very simple, as I said. I'll let you enjoy it. In the meantime, it's important to review what we call the abuse because we talked about it at the beginning, and I think it's very important to go back to abuse of you know um, percentages. Okay, very important because percentages can be so subtle. That's what we say. Many people misuse them, sometimes inadvertently and sometimes deliberately. So that's what we're gonna investigate, and the rest of the chapter. Few comments, absolute abuses of percentages. We can give you a few of them, lots of them. You know, be aware of shifting reference values. So different ways of of seeing it. Like, let's say, I think 10% cut is followed by 10% pay raise. You don't go back to the same number, right? So you don't go back to the same number. Like if you have a cut, let's say you get paid 100, let's say you get paid $500, right? Now, because the company was not doing so well, they decide, you know what? In order to save the company, I'm gonna cut 10% from your salary, but promise at the end of next of 3 months, I'll give you back your 10%. Look, 10% of 100 is like you do 10%. Oh, sorry, let me do 10% of 100. For us, it's like you do 10 over 100, right? That's $50, right? 10% over five, no, I said 10% over 500, right? So we have point 0.1 times 500, that's $50. All right, so we have $50 cut. Now, your new salary is $450 that you agreed to pay to get paid because you want to help your company. The company said, right now, we need your help to save it. I mean, your employer said, we need your help to save the company. What I'm going to do, cut you from your salary 10%, and I promise in 3 months, I'll give you back your 10%. Now, look, in 3 months, your employer respect his words and decide to give you 10% back. Look at if you do 10% of 400 now, of 450. What's gonna happen if you take 10% times 400? Oops, sorry, 10% times 450. Now you see your what they give you as an increase would be $45. So 450 plus 45, that's give you 495. You see, your new salary is no longer $500 because you don't compute. When you compute your percentages on 500, it give you $50. Now in 450, it give you 45. You no longer receive it. So that's a be aware of shifting, values, right? That's very important. Now, you have less than nothing, right? Decrease, decrease of, of less than nothing. We often see numbers that represent large more than percentages, right? Decrease calorie intakes by 150% to lose weight. That's in most cases it is possible to have less than percentages than it is greater than something. Why consider an advertisement claiming that, so it doesn't make any sense, right? Now, don't average percentages. That's very important also. Suppose you got 70% of the boys of the questions correct on the on the midterm, right? Or well, let's say 70% of the boys and 60% of the girls in the class voted to go to a water park. Then 65% of students in the class voted. That's not true, all right? So because what they do here, they take 70% and they add it to 60% and divide it by two. That's not true, right? you cannot see it like you add these two and you said, okay, this is, it's not true. Okay? Unless, they have the same weight. If it was 70-70, that would be fine. Or if it was 60-60, it would be fine. But in any way, you cannot see it that way because the difference is very meaningful. All right. So as a general rule, you should not average percentages. The only exception is when both percentages have the same basis as they do when you average scores or two of them with the same number, right? In any way, that's not possible. Okay. Now, let's see a few other examples very quick. Probably you already see it. We are ready to do some very quick ones. State whether the following statement are true or false. If a statement is false, state the true value. So that's what we're gonna do with those examples very quick, very, very, very quick. We said that uh, if the national employment rate decrease at an annual rate of 2% per year for 3 consecutive years, then the rate decreased by 6% of that rate. Is that true or false? No, that's not true. That's totally false. That's abuse of percentages. That's the same thing I said about, raise, cut 10%, add 10%. So it's false. If the national unemployment rate are, it shrank at 2% annually, it would be, you know, every times, let's say it's 0.98 times 0.98, 0.98, you need to multiply it. So that's about 5, let's say national rate. Whatever you have, you need to multiply what you have left at 0.98, 0.98, 0.98. Okay. So at that point, it is really what you got was 0.941 R. That's the weight you're gonna have at the end. So meaning it's only about 5.6% less than the original one. So it's not 6. You're gonna have 5. For this one, it's gonna be 5.9%. So sorry, 5.9. It's not 6. All right. You cannot say that. Let's go with that was A. For B, you receive, okay, that's something we need to see also here. You receive a pay raise of 6% followed later by a pay rate or pay cut of 6%. After 2 changes in pay, your salary is unchanged. Again, here it's false. We said this one false. And this one is false also. So if you add or subtract in terms of weight, that's not gonna read because assign an arbitrary number to your salary. Let's say, for example, your salary is 100, as I said. A pay raise of 6%. Let's suppose you get paid $100 plus 6% of $100. That make it 100 plus, okay, 6% of 100. Let me check it in my calculator. 100 times 0.06, you know, yeah, of $100. So you have that raise that $106, right? That's your new salary, right? Meaning, pay raise that give you that's $106. Now let's cut it. If you have a cut of 6% of the new salary, 6% minus 6% of 106, 6% of 106. Now, what this one gonna give me? Okay, 106 times 0.06, 6.36. So we're gonna have 100 minus 6.36. So what is your new salary then? nine, okay, 106 minus 6.36, you have your new salary would be 99.64%. So in any way, you see for B is also false because that's definitely not true. You know, a pay of 6% results in a new salary of 106, and a 6% cut in the new salary is 99.64%. No, your salary has changed. It dropped by 0.36% over the two change period. So very important to see it that way also. So the last one is maybe something you can verify. Also, probably false. If sales in your pizza restaurant increased by 11% one year and decreased by 3% the following year, your sales are up to 8%, which is not true again because you need to do them separately. You know, it's false. This is false, and you can follow what I just did to do the last examples to verify it. Now, let's go and see how we can complete examples in the, you know, exercise 8, example 8. Determine whether or not the following claim could be true. All right, let's go with Jane. Jane bought a surfboard online and saved 125%. Oh my God, can that be true? Okay. You buy something and you save 125%. So that means they were supposed to bring you back money, send you back money because you save more than the price of the items. Not possible. A bill can decrease at most 100%, right? Not 125%, okay? So 100% of the bill, if I owe you $200 and you said, oh, you know what? I give you a credit of 100%. That means I have nothing to give you. But if you say I give you a credit of 110%, then actually I'm expecting you to give me back. On top of I don't owe you anything for your $200, but you still need to give me money. So that's not possible. You cannot consider it. That's really abuse of percentages. Riley Riley is 200% taller than his sons, right? Is it realistic? Riley is 200 percent taller than his son. What does that mean? Yeah, at some point that's possible. That's possible. That means Riley is kind of three times 200. That would be three times taller than his sons. That's possible. If you have a son's only 2 feet and you are 6 feet, yeah, that's possible, right? Sons, they don't say his age. Probably they don't say how tall is the son. Maybe the son is only 12 inches or 20 inches or 30 inches, right? Not even 30 would be like if it's 36, that means one of them is 3 feet, the other one is 9 feet. So let's say 2 and 6, right? That makes more sense. Average hotel, well, that's possible. The second one is possible. So we said average hotel room rate increased 100% in the last 20 years. Is it possible that they increased the hotel price by 100%? Yes, that's possible because some room you used to pay only $100, now it can cost like 200. That's possible. Now, let's see for the next one about your computer. So, your computer has 200% more storage than mine. That's definitely possible. So, some computers are really have a lot of memory. So that's possible. This means your computer has three times the storage of my computer, which is definitely true, right? And the last one, it says less. Like you said, your computer has 200% storage less than mine. I mean, less storage than mine. Less not possible. You know, you said 200% not possible. Definitely not possible. At the maximum, your computer could have 100% less storage than mine. That means yours has no storage at all. But 200, that's not possible. All right. So this is at some point what we covered in section 3A. In a different video, we're going to come back to put numbers in perspective. Hopefully you enjoyed this one. I'll see you in the next video. Take care.